All right, folks. The last lesson we're going to do in Unit 4 is about something called percent of error. We're going to stop here and just kind of wrap it up next week, and we'll give you a test either the end of the week or when I see you again on Monday the following week. All right, but we're going to talk about this thing called percent of error, and this is actually a big topic for manufacturers. If you're making something important, you need to know that it fits certain specifications. And if it's outside a certain percentage of the size of it, let's say, or the weight of it, it's not what you're allowed to sell. So if you're making, let's say, cereal, for example, and your cereal box is supposed to have 24 ounces of cereal in it, if it only has 21 ounces of cereal in it, you're not allowed to sell that. It's not within the correct percent of error, percent off. If it says 24 ounces, you have to sell 24 ounces. If it's like 23.9 ounces, that's probably within an acceptable percent of error. So everything in any industry has a standard, and you have to meet that standard in order to keep your business going. So let's look at a couple of things here. We've talked about this ratio, this proportion, part over whole equals percent over 100. If I told you something like 3 out of 5, and I'm looking for the percent there, equals percent over 100. Remember, we talked about that cross multiplication. 3 times 100 is 300, equals 5 times that percent sign, or I could use 5x. And then to solve, that means 5 times x. So to get rid of that times 5, I would divide by 5, and x equals 60. That's 60%. Well, to find a percent of error, it's the same idea. We're going to use that cross multiply idea and just use different words. In the numerator, the part of that part whole when we're talking about errors is the amount of the error. How much is it off by? And then in the denominator, we have the correct amount. So there may be other numbers in there. Sometimes we have to calculate the amount of that error and think about what the correct amount is before we go ahead and cross multiply. So here's an example. If I told you, and I just made these numbers up, size 9 shoes measure 12 inches long, but if from a factory, one shoe measured 11.5 inches, what was the percent of error? So let's say for that factory, or when you're manufacturing shoes, you have to be within 1% of error, or else you can't sell it as a size 9 shoe. Maybe it's a size 8 or 8.5 shoe. So let's see, same idea here. Size 9 shoes are 12 inches long. One shoe from a factory measures 11.5 inches. What's the percent of error? Well, what we have to know is what's the amount of error? How much was it off by? Well, it was off by half an inch, right? 12 minus 11.5, it was off by 0.5 inches. The correct amount should be 12, and that equals our percent over 100. Okay, so we're trying to calculate the percent here. Maybe instead of percent, maybe I'll put an x there. And now we're going to do our cross multiplying. 0.5 times 100 is 50. And 12 times x is 12x. So again, that's x times 12. And to get rid of times 12, I'm going to divide by 12. And 50 divided by 12, 50 divided by 12 is 4.16667. Now again, the reason I like doing this cross multiply with this divided by 100 is because I don't now have to worry about moving my decimal. That moving the decimal, it's built in to this problem with that divided by 100 in there. So that would be 4.16 repeating percent. So if you have to get rid of any shoe that's more than 1% away from your 12 inches, we would have to reject this shoe as being not a size 9 shoe. So something happened in the manufacturing of that shoe, we got to get rid of it. Okay, so that's percent error, and it's important. It's an important idea if you're manufacturing or trying to sell anything. Here's another example, a little more serious here. Let's say bolts for an airplane should measure 6.75 centimeters. They can be used if they are within 0.01% of that size. Using that percent of error, what are all possible sizes for the bolts? So why is it important to have the bolt a right size? Well, if you're flying in an airplane, you want that bolt to fit safely within that airplane, right? You don't want bolts that are too big or bolts that are too small that don't fit. So again, these manufacturing standards, they're really important. This one's a little bit different than the last one. We're calculating, in this case, the size of the bolt. So let's see. The amount of error is kind of what we're looking for here. We're told the percent of error. The percent of error is 0.01. That percent always goes over 100. So I'm putting 100 there. The correct amount should be that 6.75 centimeters. What I'm going to find out is what's the amount of error that we can have on these bolts. Now when I cross multiply, I'm going to do this 100 times x, which is 100x, and 6.75 times 0.01, which is, if I did my math right, 0.0675. And then I'm going to divide by 100. That 0.0675 divided by 100 is 0.000675. So I move that decimal 2 places, 000. That seems tiny. Well, it should be tiny, right? If you're manufacturing the bolts for an airplane, we don't want them too big or too small. That number represents how far off of that 0.675 or 6.75 bolt size. So what are the possible sizes? Well, let's see. The bolt could be 6.75 plus that amount, 0.000675. So the bolts could be 6.750675 centimeters long. So they can be slightly larger, or they could be slightly smaller. If we subtract that 6.75 minus 0.000675, I get, let's see, taking out the calculator for this one, 6.75 minus 0.000675 is, the bolts could be 6.749325 centimeters big. So those are our options. We can have bolt sizes that small or this big or anything in between. Those are acceptable bolts. Anything out of that range, and they have to throw them away. So usually what will happen with a manufacturer, especially something like this, is they'll test, every once in a while they'll grab some bolts and check on them and see, how's this batch doing? And if they find that some of them are out of that range, they're going to have to reject them or go in and test more of them. Okay, so they kind of do a spot check, or maybe they check all of them, and they need to make sure they're somewhere in between those two amounts in order to be able to use those bolts. Here's a little simpler example. I estimated it would take 20 minutes to walk twice around the school. It actually took 16 minutes. What was my percent of error? So my estimation error could be found out here. The amount of my error is not that 16 and it's not that 20, right? What was my error? Well, I estimated it would take 20 minutes. It actually took 16 minutes. So the amount of my error was 4. The actual amount, I have to compare those two numbers. Which one was the correct amount? Well, that was the 16 equals percent over 100. And some of you might know this one to begin with. If I cross multiply here, that's 400 equals 16 times percent, or 16x. Dividing by 16 gives me x equals 25. That is a 25% error. Okay, so it's still that idea of part over whole equals percent over 100, and we calculate that percent. But we're just using different wording here. The part is the amount of the error, and the whole is the correct amount. Okay, so what I want you to do is a few problems in your book. We are on page 108. And we'll do a few of those problems. And again, that's going to be kind of the end of our unit on percent. So we're going to get into positives and negatives, and then into solving some equations. We'll do as much as we can. But the year's almost over, guys. All right, have a good night, and we'll have a good weekend, and we'll see you soon. Bye-bye.